Hey guys, today I just wanted to go over our next set of notes or idea here. So no real specific notes. You have a handout here which is labeled VSEPR Theory. And VSEPR Theory is just a way for us to take our 2D Lewis dot structures and transform them into a 3D model. Because molecules are in real life, and in real life we are in the 3D. So we need to be able to visualize what they look like. So on this handout, I want you to highlight a couple things, and these are really going to be the only things that you have to worry about with this handout. So we have generic formula, picture, molecular shape, and then bond angle. So it seems a little confusing at first, but the more we get through this, the easier and more it will make sense. So a couple of things that we have to keep in mind is that we have, for this generic formula, you see it's in an A, X, or E. Well, what does A, X, or E mean? A is the central atom, X is any atom that is bonded to A, and then E is going to be a lone pair on A. So let's go through a couple examples together. So our first example is CS2. So our first step is to determine how many valence electrons do we have in carbon and how many do we have in sulfur. So carbon we have 4, sulfur we have 6. So carbon is 4, sulfur is 6, and we have 2 of those, so we have a total of 12. So that's going to give us a total of 16 valence electrons for us to work with. So that is our total. So when we draw our Lewis dot structure, we have carbon in the center, and then we have 2 sulfur atoms on the outside. Right now they are only single bonded, which gives us 4. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So carbon does not have its octet because it only has 4 around it. So what we're going to do, we're going to take 2 from each sulfur and make it so that there is a double bond. Okay, so A will always be our central atoms for determining what is known as our AX type, or over here, that's just the generic formula. So we always have an A. From there, we have to determine, do we have any X's or any E's? So X is how many other atoms are bonded to the central atom. So in this case, we have 2 X's, so A, X, 2. And we have no lone pairs on the central atom. So a lone pair would just be 2 electrons that are on that central atom, which we don't have. So AX2, so we're going to come over back to our chart here. We have AX2 right here. That gives us a linear shape, which provides us this 3D model. And it tells us that the bond angle is 180. So our shape name is going to be linear. Okay, and then we're just going to redraw the picture here. So we're going to have, but instead of with our carbon and sulfur, we're going to use the AX type. So we'll have A in the center, bonded to an X, bonded to another X, and then we're going to draw the angle here. So it's going to be our angle, and that is going to be equal to 180 degrees. So I'm just going to add that right over here. Okay, and for this one, it asks us, does it have resonance? So remember that resonance means can the double bond be in a different place? And for this, the answer is no, because we already have 2 double bonds and there's nowhere else for that to go. Now, if we only had 1 double bond on one side, and say this other side was a single bond, then yes, it could have had resonance. But in this case, the answer is no. Okay, and then there's this last column here that says polar. We're not going to worry about that today. We will learn about polarity in a couple days. Okay, moving on, we're going to do number 3 together. So number 3, we have oxygen, which if we go to our periodic table, oxygen has 6 valence electrons. Well, 6 times 3 gives us 18 valence electrons to work with. So when we fill this in, I'm going to kind of fill it in right here, kind of small. Okay, so I've used 4. All right, so we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So notice that our central oxygen, so our central atom here, it does not have its octet. It only has 6. So we need to add a double bond. And for this, it doesn't matter which side our double bond comes from. It could come from the first oxygen here, or it could come from the third oxygen here. So what we're going to do, we're going to get rid of 2 of those valence electrons, and we're going to move them on to the double bond. So moving those out of the way. Okay, so again, notice that now we have our double bond here. This double bond could have ended up on this side, or it could have easily ended up on the other side. So before we move any further, we're going to write down that this does have resonance, because that double bond could move around. Okay, so now we have our AX type. So we have our central oxygen atom, so that's an A. It has got 2 bonded oxygen, so that's going to give us AX2. And then we have these 2 lone pairs. All right, so a lone pair means 2 valence electrons. So we have 2 valence electrons that are on this central atom, so that is going to give us an E. So when we go look at this on the chart, we have AX2E. That gives us a bent shape, and so it'll look something like this. So we still have our A as our central atom. We have those X for our 2 bonded atoms. And then our lone pairs are just going to kind of sit up here on top of the A, just like that. All right, we've got a couple more that we're going to do, 3 more to be exact, and then you will do the ones that we don't do on your own, simply because they're going to be one of the 5 that we complete. All right, so we have CCl4. So Cl is 7, and 7 times 4 is 28, and then we have carbon, which is 4, so that is a total of 32. So we have carbon as our central atom, connected to 4 chlorines. Make sure you're careful in writing those out. Okay, so I've used 8, so 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, Everyone has an octet, so they're all got 8. So then our AX type, we have A, X, and we have 4 X's. We have 1, 2, 3, and 4. So when we go look at our chart here, we're looking for AX4, which is right here. That gives us this shape here, and that is known as tetrahedral. Real fast, I do want to go back to our bent shape and just make sure to add that our bent had a bond angle of 120. Alright, so this molecular shape is going to be a little different because if you notice we have these like this solid triangle and this dashed triangle, and that just means that we have something that is coming straight out and then something that is coming behind. And again, this will make a little bit more sense when you see this in person. So we have our A with an X coming up top, an X coming to the side. We're going to draw a triangle and fill it in. And we have X. Then we have a dashed triangle. That signifies that something is going in the back, so behind, and that is another X. And if we look at our bond angle, that gives us 109.5. Okay, next one we have is NF3. So fluorine is 7, nitrogen is 5, so that would give us a total of 26. Okay, so nitrogen in the center, surrounded by 3 fluorines. And then we just gotta count up, so 3 fluorines. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make that a little bit more towards the F. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25, 26. Okay, so we have A, 3 X's, so AX3, and then we do have a lone pair here, so that would give us an E. So if we go look at our shape, so AX3E, this gives us trigonal pyramid with another bond angle of 109.5. And so for our trigonal pyramid, it's very similar to the one above. So we have our A, X, our lone pairs, our dashed line with our X, and then our solid triangle with our X. Okay, and this one doesn't have any double bonds, so it would not have resonance. And I meant to say that one to the earlier one, so CCl4 also does not have resonance. Okay, let's go ahead and we're going to move on to the second one. Well, second page. So go ahead, flip your paper over, and we're going to look at number 7. Okay, so this will be the last one we do. So we have SO3. So go ahead and calculate how many valence electrons you need. Okay, so oxygen is 6, so that would be 18, plus another 6 from the sulfur, which is a grand total of 24. So when we draw out our Lewis dot structure, we have our sulfur and 3 oxygens. And then we're going to fill in our dots. Okay, so that gives us an AX type of AX3, and we have no lone pairs, so that gives us the name of trigonal planar. trigonal planar.